All right. Welcome, everybody. We've got a good crowd here this morning. I think we're expecting a few more, but we'll get started. We are recording this session, and it also is being live streamed on YouTube. I will share that URL here shortly once I pass off to Nick, who's going to be our speaker today. Nick Lotz is a developer advocate at Harness. He's been kind enough to give us some time here to share his knowledge on GitOps and Terraform. Lots of useful information, hopefully, for you to use in your own daily work. And looking forward to that talk here momentarily. As mentioned in one of our tweets, if you saw it, if you didn't, then it's maybe a nice surprise for you today. For attending today, there's a discount code if you'd like to attend KubeCon Europe. That's in March of next year in Paris. And if you're wondering if you should attend, well, Paris, why not? There's a code for you on the screen. If you follow that QR code, you'll go to the registration page, or I should say the conference page for KubeCon Europe. You can register later using that discount code. I am going to stop sharing and let Nick take over for the main event. So take it away. Thank you.
Yeah, thanks, Matt. And just kind of going off the KubeCon discount code for a moment, I happen to be sporting my KubeCon North America shirt from this past November. And I can't recommend the conference highly enough. If you've never been there before, they generally put on a great conference. Whether you're there as a learner or a vendor, you always learn a lot and meet a whole lot of great people. So again, obviously the icing on the cake is it's also in Paris for KubeCon Europe. But again, it's a really, really great event. Okay. Well, hi, everyone. If hopefully everyone can hear me. We did a tech check earlier, and I think I'm sharing everything okay. Obviously, let me know if I'm not. But my name is Nick Lotz. I work for Harness as a developer advocate. The focus on this talk is going to be on GitOps, and the topic is automating your source of truth. And another way you can think of it is automating the automation. The folks on this call are hopefully, familiar with some cloud native concepts. Maybe whether you're a developer or a platform engineer, you've worked with automated tooling of some kind, whether it's configuration management or domain specific tools. You may have heard of the term GitOps before. If you haven't, I'll go into that as well. But really, the goal of this talk is to understand and also come away with some practical examples of the purpose as well as the challenges, and then some practical tips of examples of when teams, particularly enterprise teams, go about using declarative automation to manage their resources, deployments, environments, and platform workflows. So that's going to be the focus on this talk. Kind of the tools used in this talk are going to be Harness. So I work for Harness as a kind of representative CI/CD tool. Terraform will be the declarative management tool we'll be using. But again, a lot of this will be concepts as well. So whether you use Terraform or OpenTofu, which is effectively the same thing with regards to what we'll be using, or other declarative tools, ultimately you'll be coming away with concepts as well. But so in terms of a little bit of my background, as mentioned before, I'm a developer advocate at Harness. My background is largely in the infrastructure and automation space. So I made the start of my career working with enterprise Linux and kind of the stack of enterprise Linux, Ceph storage. I worked with OpenStack for a little bit, Cloud Foundry, sort of moving up the infrastructure layers. And for those who have that kind of background as well, you probably remember that things get more and more development heavy as you increase the level of abstractions, right? As a regular sysadmin, you might be following imperative runbooks, but once you start using cloud native tools and Kubernetes and the associated supporting tools, you start thinking a lot more of a developer. Sometimes you even start thinking of like a computer scientist and a systems engineer. Is you have to manage dependencies and all of the interlocking parts of complex systems. And that's kind of a good segue of what today's talk will be. So we're going to start off a little bit conceptual. We're going to talk about kind of the background of how we got here. I won't spend too much time on it because I think a lot of folks in technical communities have at least an idea of the evolution of platform engineering over time and shift left and DevOps, but I'll do a little bit of a review. And then I'll introduce GitOps. Again, if you haven't heard of GitOps before, the term is somewhat of a self-descriptive term of two words, Git and Ops. And the idea is managing your operations, automating it with the backing of version control. And ultimately, that's easier said than done. And we'll talk about the benefits of and challenges of that approach. And then we'll start thinking about, once you've gotten through maybe the day one and day two challenges of GitOps, what do teams tend to run into? And then how can you manage those additional challenges? Really, what we'll learn is that you can run into a complexity problem and problems with abstraction that require additional management layers that might not have been anticipated at the beginning. That is, how do you automate that which you have automated? How do you manage the tools, now additional tools that you've used to automate and declaratively manage all of your resources in the first place? There'll be a demo. So again, saying kind of a short prayer to the demo gods, as always, before these kinds of talks. But I do have one set up that'll hopefully provide, a demo, but a realistic look at how declarative tools like Terraform can be used to manage not only the baseline infrastructure, but also the supporting tools that are used to manage your automation in the first place. At the end, we'll hopefully have about 10 or 15 minutes for a Q&A as well. So again, feel free to hold your questions and then ask them as well during the talk, or sorry, during the Q&A. Okay, let's start with a little bit of background. So everything is now software defined. Mark Andreessen came out with a famous article in the Wall Street Journal about 12 years ago, now called "Software is Eating the World." And back then, he made at the time, somewhat controversial statement that every industry in the world is going to be managed by computers, right? It's not just confined to what was that at the time, Web 2.0, right? The Silicon Valley internet companies, but cars and factories and chemicals and transportation and construction and all pretty much cuisine, food, all industry everywhere will ultimately be run or managed with software layers. And I think we intuitively know today that that is in fact the case. Software is now used as sort of the language to define all sorts of things we use today. Not everything, but practically every industry is affected by software. During quarterly earnings calls, right? You see CEOs constantly talking about how they use software to automate and make efficiencies in their own business. Every company, to an extent, is trying to become a technology company. And what that means is, regardless of what your core business or core, whatever your core mission is as an organization, when you add software on top of that to run your organization, you're using software to maintain your underlying systems, but you also bring in tools to run and maintain your software tools. So as a systems engineering problem, you need to maintain the systems you're using to maintain your other systems. It becomes a little bit of a chicken and an egg problem, where if you are automating, some sort of business processes or software processes or workflows, well, how do you automate the automation? Like, what do you use to manage the tools you're using to automate in the first place? And all that means is really that the software crisis is real. So the term software crisis is a bit of a history lesson, came from around, over close to 60 years ago today. There was a NATO conference in 1968, and the computer science field was just starting to come into focus. It was just starting to be defined as a field of study, and software engineering as a discipline. Now, at the time, the term software crisis was referring to the fact that the way software was developed back then, there was a hard line between designers and implementers. At the time, to a great extent, programmers were thought of as human calculators. The designers would do all the work defining the specification, and programmers would simply just implement the specification, but they would do no extra design or deviation themselves. I think we all know today that that's not the case. Programmers have to be creative, and developers themselves act as engineers making design and implementation decisions, because that's required when developers have the subject matter expertise around the systems they maintain. But the lesson from that conference and the term the software crisis really has come to mean that complex systems without care and careful design trend toward brittle and expensive. That is, when you make a choice to bring in a new tool in an attempt to make your life easier, that tool also needs to be maintained. And then you can run into another term, which is called dependency hell. It becomes really difficult to keep everything working properly without kinks in the hose. And your entire system becomes opaque and difficult to maintain. In addition to that, again, as computers have become part of all we do every day, there's an entire cottage industry of how to manage the complexity. So that can be in the form of O'Reilly books, it can be in the form of consulting companies, it can be in the form of papers. The entire discipline of site reliability engineering, which was largely popularized by Google, has come to represent how do we manage using software, the software that we maintain. There's entire job descriptions now that are like small pieces of the software engineering discipline as well. Really getting now into the focus of this talk is, as maintaining systems have gotten more complex, alongside that has come the rise of desired state development. And if we think about the motivation of desired state development, think about what else you do in your life. So imagine that you're planning a very large banquet or wedding, for example. If you were to plan that in a completely imperative way, right? Start at square one. You might think of I don't know, grow the tree that represents the wood that represents the building that we will house the event in, right? Like in today's world, no one really does that. Rather, you rely on experts and tools and an ecosystem of event planning to get the result that you want, right? The couple that's about to get married will say, I want these things in my wedding. And then, if they've hired a wedding planner, the wedding planner will go through the steps to make that happen. And when we apply that to software, desired state development, rather than do these things, start with A and end in Z, it means give me this outcome. That is, you're using tools to abstract the underlying automation. Rather, you say, I want these resources, these virtual machines, these network interfaces, these virtual networks, or even higher up the stack. I want these application deployments, or replica sets, for example, or services that have been deployed. And again, the tools perform that work. And over the past, especially 5 years or so, declarative seems to have mostly won out as this desired model. When we can, right, rather than getting into the weeds of imperative type work, we use a tool that allows us to declare what we want, and then our differentiators will be, the particular business or mission logic we add on top of that. Again, the focus is on business logic and governance. Let's differentiate what makes our application or our software we're developing, what makes that special, and then let tools that have had wide adoption do the plumbing under the hood to manage all of the supporting infrastructure and resources. We're abstracting away from the plumbing of imperative runbooks, where releases take weeks and weeks because you need to check all these boxes. We rely on software to manage the underlying state and reconcile any deviation from that state. So there's a paradox, though, that comes with this. Automation is supposed to reduce our manual workload. At the same time, it's another tool to set up and maintain. So there's always some initial grunt work at the beginning where we're hoping that the upfront investment of understanding and using some sort of automated tool it makes ultimately saves us, time and resources in the long run. And the goal also is that automation maintains consistency and reliability in our infrastructure, but only if the automation itself is reliable and consistent. If you were to look at the top ranked questions of using tools like Terraform, when people ask what is the biggest challenge in using tools, the plan and the apply don't give you the same thing, right? The point of desired state tools is that whatever the state they calculate is supposed to be exactly what you see in real life in your live environments. And declarative GitOps tools work when that's the case. If there's some kind of drift or deviation, then you run into problems debugging and trying to make your live environment represent the configuration you've defined in version control. And then again, automation allows for a declarative source of truth so we can focus on the end result. But at the same time, we also must know our desired final state. This is a classic case of the computer just does what we tell it. So if we don't understand the layers of abstraction, if we don't understand what exactly it is that we're trying to maintain, the computer is just going to do what it's told. So there's an education requirement here as well, that engineers should understand, even if they're automating it, what it is that they're automating. Okay, so let's kind of get a little more concrete here. Everything I've talked about so far is a little bit, kind of a conceptual. Automation is good, but it can cause problems. I don't think that's controversial. The term of art in the industry that represents this declarative model is GitOps. Essentially, treat operations like development. The term GitOps was believed to be first coined by Weaveworks around 6 or so years ago. The kind of Wikipedia description is an operational model that uses Git as the single source of truth for declarative infrastructure and applications. So GitOps is declarative. We say what outcome we want. We don't directly say how we get there. The automation tools perform the necessary steps to get that outcome. A key point as well is that it is versioned and immutable. That is, you're treating GitOps like commits to a Git repository. That is, when you create a commit, that commit is immutable, represents your immutable state. And then you create a new commit that represents some kind of change, but you have that chain of version history that you could revert back to if needed, or reference if needed. It is also pulled automatically. So a big approach to GitOps is a pull-based approach, because your version controlled configurations represent your source of truth. Whatever software you use to manage GitOps, rather than pushing changes to the live environment, or rather pulling changes from version control. That is, we let the environment update by pulling changes based on what you have in the repo, rather than some sort of imperative push or imperative nudge by making manual changes to a live environment. And then under a similar vein, resources are continuously reconciled. A big problem of engineering and research in this area is that of drift detection and reconciliation. What happens when your live environment drifts from the ideal declared in your Git versioned code base? Well, there needs to be mechanisms to ensure that the environment is brought back up into sync with what you have defined as your ideal configuration. So GitOps, you're hopefully familiar with the term DevOps. It's a very similar conceptual construction. Like DevOps, it's a combination of culture and tools. So I have this little graphic here, and the idea is that all the resource configurations that represent infrastructure, application and deployment configurations, your application code itself, all of that is version controlled. We're not really getting into like a mono repo or poly repo approach here, but the idea is that it's all stored in Git. And then your automation tools will pull from those configurations to update your live state. Again, the example here is that we might be running resources in one or more Kubernetes clusters. And common open source tools include those like Argo and Flux, right? Argo and Flux are GitOps CD tools that act as deployment and continuous reconciliation tools to take what you have in version control and then update, in this case, your clusters accordingly. So your Argo and Flux tools in this example, these act somewhat as agents, we can think of them, that make sure that your clusters reflect what you have in version control. The reality, though, is that you're always going to need management on top of that. So the example I have up here, this is the logo for Harness, the company I work for. And Harness creates additional management and abstraction layers, because just having version control and then GitOps tools like maybe Argo and Flux, that solves part of the problem. That gives you, that does give you a pure GitOps model, but you still have challenges like access control and secrets management and governance. And what happens when you occasionally need to make the imperative change? Like, what does the workflow look like for updating your configuration in the first place? That's a problem not directly addressed by pure GitOps methodology. How do you update and change your resource configurations in the first place? That becomes an imperative workflow that you have to a little bit add on top of your declarative models that you have in Git. You're always going to have to do some kind of work, and you're going to need management and some sort of tools layer to represent the changes you make to the resources you've deployed. So everything I've talked about so far is sort of an introduction to GitOps. And for those who have used GitOps before or used these types of tools, you're probably familiar with the need to construct a tool chain. And then you're probably also familiar with the complexity that can result from that. So moving back to the software crisis explanation I gave earlier, the question then becomes, like, how do you automate all of this, right? You have version controlled configurations. They get pulled into live environments, and there's software like Argo and Flux that maintain those environments. But you still need to deal with governance, like I mentioned before. You need to deal with observability, like what am I deploying? So you might implement Prometheus and Grafana or other observability services. You need to deal with reconciliation. So however you define your your application deployments, if it's Kubernetes related, you might be using Helm, you might be using Kustomize, infrastructure, Terraform, Crossplane. Whatever it is, whatever declarative state tools you use, what happens when your environments drift from the ideal configuration you've specified using these tools? And again, going back to what I mentioned before, let's look at this pipeline piece at the bottom. Whenever you make changes, there's always going to be, on top of the declarative model, there's always going to be somewhat of a linear aspect to change management. Over time, we've made layers of software that declaratively manage the layer of software underneath. Again, we have infrastructure that's managed using Kubernetes, which is declarative, and then we might use tools like Terraform to manage Kubernetes even more. That makes it even that's another declarative layer. But ultimately, we need to change our configuration somehow, and that tends to result in a developer or platform engineer going in, making a change and a commit, making a pull request. There'll be some kind of review and approval, and then you update the configuration that will then be pulled to your live environment to change your live environment to represent your what's in your version control system. So what you ultimately need is you hopefully also develop a rigorous workflow for defining how you make those changes. So this is just an example pipeline below that shows some of the gated processes for how you update your configurations that are stored in Git. So there might be, even on top of your existing GitOps automation, automated processes for updating your repository. There might be gated approval steps where, as you promote from maybe a dev environment to a staging or prod environment, there are team members or teams that have to do additional review and approval, even outside the typical, development code review process. You might require that all commits to the main branch that represents your prod configuration has to go through a particular pull request workflow that might represent, some ticket or change management ID. And then finally, once all is said and done, there's going to be a synchronization step required. How do we ensure that our live environment is fully in sync with all the work that we've done to update our underlying repository. So again, this sort of thing here at the bottom is not normally pre-baked in GitOps tools. Tools like Argo and Flux, they're meant to automate and reconcile once the change hits your version control system. But everything around, the pipeline steps you might need, the governance, the observability, that's not pre-baked, and it's helpful to have resources that manage that as well. So if we think about how we're mapping everything we've talked about to relevant tools, teams normally piece together a required tool chain using Git generally as source code management. There might be testing suites they use. If you're talking about it like already provisioned servers that you're then configuring, you might use configuration management, Puppet, Ansible, Chef, tools like that. Infrastructure as code. Terraform tends to be, and OpenTF and OpenTofu now are now, tend to be the prime tools for that. Argo CD and Flux for GitOps deployments. But even with an established open source tool chain, you still need to handle things like change management for application versus infrastructure. So focusing on this for just a moment, generally, your application deployments are defined using things like Kubernetes manifests, for example. Lots of deployment manifests, values.yaml. The infrastructure itself, I'm talking, represents things like our networking and our Kubernetes clusters themselves and the nodes that we have and any kind of auto scaling we have in place. If you look at most declarative management tools, it is tough to manage the dependencies between your infrastructure and what you're deploying. The reason for that, for example, if you're talking about a Kubernetes cluster that you're maintaining using Terraform and what you're deploying to that cluster, you generally can't do both in a single Terraform apply, or it's difficult to. There's a lot of kind of hacky ways you need to go about to do that. The reason for that is Terraform doesn't know what the cluster exactly looks like until it actually deploys to it. So there's a lot of like open source and community providers that try to deal with that problem. But even if you look at the official Terraform documentation, it tends to say along the lines of, we recommend you have your infrastructure resources and Kubernetes resources in two different Terraform modules, and you'll apply one and then apply the other. So you need to do work to handle change management for different aspects of your environment. Synchronization, again, how do we get the application in our live environments looking like what our configuration is supposed to be? Governance, auditing, role-based access control. And then advanced deployments as well. Canary, blue-green, incremental rollouts, chaos engineering. Those are all items that are additional areas of automation and additional abstraction layers that need to be handled. So really, all this to say is that the approach that works the best is normally a both-and approach. That is, leverage open source tool chains and then use the right tool for the job. So again, the company I work for, Harness, we add additional layers of abstraction to manage the end-to-end GitOps process and add those pieces: observability, access control, advanced deployment pipelines for managing the updates to your version control in the first place. The question still remains, we're adding another tool. Like, how do we make our life easy so that adding another tool isn't just another tool to manage, but we come out ahead where ultimately time and resources are saved and we don't spend more time and resources just managing the tool we've added. And that's where, in a sense, reusing and leveraging your existing declarative models can help. So this last piece is going to also transition to a demo. There are tools like Terraform that can be used to unify our automation. And infrastructure as code is one good way of having sort of a parent level management layer of managing not just our underlying infrastructure, but also the software we use to manage our underlying infrastructure. Terraform and OpenTofu have evolved to become very kind of broad-based declarative tools Like they can be used to manage software resources of almost any kind, as long as you've written a provider to manage those resources. So teams already use IAC tools to automate their infrastructure. And you can do the same with GitOps and its management entities. So Terraform has providers for Kubernetes. It has technically providers for like GitHub repository management. So if you're trying to just manage the environments that your repos live in, Terraform has providers for that, including community providers. And Harness has a Terraform provider as well. When you make resources inside Harness, so as a quick example, this is what the kind of GitOps management layer looks like in Harness. There are entities you create like cluster mappings and repository references and the applications you actually deploy. These are software entities that live in Harness, and you can create those imperatively by clicking around the UI or the command line. But these can also be managed in a declarative version controlled state, just like all the other resources that you're trying to manage using version control. So when you're using Terraform, the idea is we're managing both our infrastructure and our applications using a unified tool in this case. All right. Okay, so how does this map to a Harness GitOps model? So what I'm going to do in a moment is show this through a demo, but ultimately all the different entities you're creating are managed in a Terraform module, and that create a unified Terraform state. So Terraform is going to act as our tool of choice to represent the configuration of our software-defined infrastructure. We're also going to have continuous state reconciliation based off any changes to our Git repository. That's going to be handled using Argo, but the Argo resources themselves will be managed through Terraform. It'll also make our life easier when it comes to collaboration and versioning. So again, any kind of third-party entities we're making, which will be Harness entities in this example, that act as the management layer to manage what we deploy to our environment, our cluster in this instance, these can also be version controlled and be specified as code in our code base, which allows for code review, your choice of Git flow, and your choice of repo architecture. So again, to just hit the point home, right as I do my demo here in a moment, these entities are ultimately software abstractions. These software abstractions, these Harness entities, are meant to provide a management layer. Think of it as a framework to manage the what and how that we deploy. The actual what gets deployed is going to be Argo and its associated resources that live inside our cluster. And then our application itself is what's being managed in our cluster as well. So here I just have a kind of what's the equivalent of a basic hello world application called Guestbook, but that's what gets deployed. All of it is going to be managed using Terraform, both the application configurations, the Argo configuration, as well as the Harness entities that we're creating as well. All right. Okay, so let's do a demo. And right as I move into this demo, again, this is going to be what I'm setting up. One more really important reason to use declarative tools like Terraform is it also helps you map out what your dependencies look like. So if you're unsure which resources depend on other resources, once you start to do the hard work of trying to Terraform it out, you can use tools like the Terraform graph utility to kind of create a mapping of what are all of the resource dependencies in your environment. And for example, what needs to be created before another resource is created, or what needs deleted first when you're performing cleanup. That becomes really useful, and I'll show an example in a moment. Okay, so I have a box set up that has a directory. This is just a Linux box, and there's several Terraform state files in here, several Terraform files that represent a Terraform module. And all of these files contain the specification, following the specification of, in part, the Harness Terraform provider, of what I'm deploying. So for example, this is the Terraform file that will help me deploy my guestbook application as an entity in Harness that also represents my actual deployment in my cluster. Speaking of which, I also have access to a Kubernetes cluster. Let me make sure I share that. Sorry. I forgot to switch my screen over here. I have access. So again, I have access to these Terraform entity files here. I also have access to a cluster, and I'm going to deploy to this cluster. So this cluster right now has nothing on it other than kind of the default Kubernetes namespaces. These Terraform files, which by the way is also in a public GitHub repo, these files contain not only my cluster deployments, but also the Harness entities that manage that deployment. So if I run, I'm not going to go, for the sake of time, get into the weeds of each of these files right now. But if I run a Terraform plan, I'm ultimately creating 9 resources. And something you'll notice is that some of these resources are directly referencing the Harness resources I referenced earlier. So these are actual Harness entities being created. Some of these are also being made in my local cluster. And notice that when you're using tools like Terraform, you often run into a situation where you make things as declarative as you can, but especially when it comes to like local cluster deployments, you end up doing a little bit of like direct command execution as well. And again, this is just a challenge in the GitOps paradigm, where I'm going to create an agent specification that'll represent my Argo agent, and then I need to deploy that agent to my local cluster. And to do that, I'm actually going to run once a manual kubectl apply. So there's still challenges to be worked out in terms of how declarative you can make things, or occasionally going to have the occasional imperative step there as well. But right now, I don't have any of these resources created. I don't have anything deployed to my cluster. But if I now run Terraform apply, it's going to start deploying. And what it's doing first is it's creating the Harness agent, which it just made. That's currently coming up. And it's also creating the associated cluster resources. So it just created a bunch of Argo pods, as well as the Harness agent pod as well. And again, this is the entity that needs to run in our local environment so that it can pull from our code base whatever changes we make. So these will be fully deployed in a little under 30 seconds. And then the other management entities will be created as well. So again, we have these resources being made here. The Harness resources aren't quite up yet, but they'll be up in a moment. And it appears to have worked. Again, no errors from Terraform side. If I run Terraform state list, we have our entities that Terraform says have been created. If I go to Harness, we now have resources that live in Harness. We have entities representing our cluster, our repository that contains our application source code. And we also have the application deployment itself. Again, this Hello World app called Guestbook. And if I click into Guestbook and I see the resource view, we actually see what was actually deployed. So ultimately, we have a replica count of 3 if I start from the right here. So we have 3 pods that I'll confirm in a moment were actually deployed. We have a Guestbook service. And then again, our 3 pods represent our actual deployment in our environment, all managed by this GitOps application entity. And in this case, they're all living in the same namespace, just for the purposes of this example. So I didn't deploy to a different namespace, which you can absolutely do. But ultimately, if I run kubectl get pods, we see that pod count represents the replica count that we saw in the resource view. And again, the idea here is we have these entities managed using those TF files that I had in my directory. So again, Terraform state list tells me what I deployed. Terraform destroy would remove all the deployment and all of its relative dependencies. But what's also useful to just sort of finish up this example is once you start using tools like Terraform to automate your automation, you also can do dependency analysis. So there's a command called Terraform graph that will output what your environment looks like, what your resource tree looks like. And if you look at the Terraform graph documentation, you can easily redirect it to like a GraphViz utility that can actually kind of pretty up and turn into a picture your dependency tree. So Terraform graph on its own is just going to give you all the relationships. But if you redirect it into a tool like GraphViz, you end up with a picture that can look something like this. And this shows what all the different dependencies are. So in this case, my kind of root dependency is that agent, right? I need an agent in my cluster that can perform execution before I can create or deploy anything else. But this also shows whatever tool you're using, in this case, Harness, what the different Harness relationships are that are required. So for example, I have a cluster and a repo resource, and I need my cluster and my repository before I can create my application. I need both of those before I can map them to an environment that's used by my application. So as you start using these tools, you can start to get a more objective view of the required mappings to all your resources as well. All right. So with all that being said, that just about covers everything I wanted to talk through. And again, the core lesson here is that creating layers of automation requires work, but you can come out ahead if you're proactive about managing the additional layers that you're using, the additional supportive tools that your company has adopted or has purchased from a vendor. And that's a way you can actually come out ahead, is by being proactive about using declarative state tools to handle even the supportive tools you're using to manage the underlying plumbing. So with that said, thank you very much. I would love to now take any questions that folks might have. I've been kind of monitoring chat as well, but feel free to ask any questions as well.
Thanks, Nick. By the way, I just suggested if folks have a question, maybe they can use the raise hand feature and we'll call on them so we don't have people, speaking over each other.
Where are we deploying these agents? Sorry, I just saw in chat there. Great question. Okay, yeah, and let me go back here. So this is a really actually it's a nuanced point. So if I go back a couple slides, there's a few resource areas that I'm talking about. Let's focus on the right side of this graphic. Okay. I have an agent that runs in my cluster, and the agent, for generally networking reasons, is required to run in my environment so it can perform execution work. So the management happens, in this case, in the Harness SaaS platform. So the Harness SaaS platform is accessed over the internet, and this is where I can perform like management activities. Whatever change I make in Harness, or whatever Harness entity I change in Harness or in Terraform, that's picked up by the agent that lives in my cluster. Now, if you're using a tool like Harness, the nuance is you see the entity referenced in Harness. So this is like the agent entity that you see from Harness, and you see the mapping here, but the actual agent resource lives in my cluster. So this agent resource is performing execution steps, for example, using the Kubernetes API based on instructions given to it by Harness, and in my case, by Terraform as well, where I'm creating these Harness entities that create the application entity that ultimately tell the agent to perform the necessary steps to make whatever lives in my cluster look like whatever I have defined in my code base? Great question. All right. Is this agent per cluster? Not necessarily. So what's nice about tools like Harness is that you can manage multi-cluster deployments. Generally, when you have the underlying open source tools like Argo and Flex, that normally requires an agent per cluster, but Harness becomes more abstract. So to answer your question is, when you're looking at the actual pod that represents your agent, yes, that will be per cluster. But when you're talking about the management layer that you're using in Harness, you can perform multi-cluster management using that. Great questions. Any other questions from the group? All right. Yeah, how does GitOps interact with the agent? Another great question. It's a pull-based approach. So if I go back to, let me go back a few slides to here. Ultimately, when you make a change to your repository, you are not pushing those changes to the cluster. So you're not, as is the Kubernetes model, you're not pushing your changes externally into your cluster, because generally that's difficult to do, at minimum from a networking and firewall perspective. So the agent is constantly checking in to see what has changed. And then when you make a change to a repo, for example, and performance, the agent will pull in any changes to the configuration and reconcile those changes with what's been already deployed to the cluster. So the agent, again, does the work and heavy lifting of reconciling changes through a pull-based approach, pulling to the cluster. What is the frequency of this change? I don't know off the top of my head, generally in the matter of seconds to a minute. I would have to look in the docs to see exactly how often the Harness GitOps agents listen, but it's a pretty consistent heartbeat. Is Harness used to create the Kubernetes cluster and cluster resources through Terraform? So in the example that I did, Harness is not used to make the cluster itself. So I already created the cluster. I just have a local K3D cluster to make my life easy. But it could be any cluster, cloud hosted, on-prem, a Kubernetes cluster in my example. In my example, Harness created the resources, Harness deployed the resources to the cluster using the GitOps agent. Terraform can also be used to create the cluster itself. So Harness can also be used through, at minimum, through a pipeline approach, to where you specify the Terraform module that creates your cluster using, in whatever cloud provider you want, or if it's a local on-prem, and then resources get deployed to that cluster. I mentioned before that there's generally engineering work that needs to happen there at minimum, because when you use tools like Terraform, Terraform struggles to deploy to infrastructure that's being created using the same module, using the same plan. It becomes a chicken and an egg problem. So in this example, Harness was not used to make the cluster. It was used to create the cluster resources. Harness can also be used to make the cluster itself alongside, using Terraform and things like Harness pipelines. All right. Great questions. Any others from the group? Matt, I think that covers things from my side. Yeah, thank you all so much. I'm happy to hand off to you or put up this slide again.
Yeah, thanks, Nick. I think if you would stop sharing, I'm going to put up a slide for folks, if you don't mind, to take less than 90 seconds really to do a quick survey. Let us know what you think about today's talk. There's an opportunity to give us structured feedback, unstructured feedback, also an opportunity for you to let us know if you're interested in I see another question, by the way. I'll let you answer that in a second. But there's also an opportunity in the survey to let us know if you're interested in talking at a future event or hosting one, or what your involvement, if you're interested in being involved going forward. For sharing the presentation, so this is being recorded, and I will share that on YouTube, send everybody an email with a link to that on our YouTube channel. Actually, maybe I'll just put the YouTube channel link in here in chat in a second. So you'll be able to review the recording on demand anytime you want. You'll see all the slides, and all the chat, all the speaking will be part of that recording as well. Nick, do you want to answer that? Who is the provider of GitOps agent?
Yeah, real quick. It is Harness. Something I kind of abstracted away in my example is that if you were to do all this through the Harness UI, you create the GitOps agent entity in the Harness UI, and then that step then spits out and provides to you a Helm chart or manifest that you then deploy to your cluster. So Harness provides the agent manifest that's kind of auto-generated if you go through the UI route, and then you provide it to your cluster. I did all of that through my Terraform module. So I created the Harness GitOps agent entity, and then Terraform pulled the manifest from that and applied it to the cluster. So that also deploys Argo. So it deploys the Harness GitOps agent, which includes the Argo entities as well. But Harness, it's done through Harness.
Excellent. I put a link to our YouTube channel where you can find the recording. And just want to say thanks again, Nick. Thanks, Harness. Thanks, Nick Acton, who's on the call here as well. And thank you all participants for joining. Hope to see you again at a future event.
Thanks again, everyone.
Bye.